Dear students, in this video we are going to discuss laser. What is mean by laser? Laser mean light amplification by stimulated emission of radiation. Now we will discuss that what is the laser device and how we can use the laser. How in laser we will discuss that how to produce the light waves which are all in steps. So the laser is a device that produces the light beam some remarkable properties. So what here we are going to discuss some properties of laser light. Firstly, the laser light is highly coherent. That is, light is highly coherent. Here the coherent means that all are in phase. And secondly, the light is very nearly monochromatic. Light is very nearly monochromatic light. And monochromatic light means that light is of single wavelength. And third important property of laser light is that laser beam hardly diverge. Laser beam hardly diverge. And this is very remarkable property of laser light, as because of this property we can choose the laser light in astronomical application and astronomical application as well as in some other application, like we can send a laser beam, we can send it deep into the sea, and also we can send a laser beam into the space to find some target. So laser beam is hard because it hardly diverge from its path. And another important property of the laser light is that laser beam is highly intense. Laser beam is highly intense. And we can say that it is more intense by far than the light from any other source. So to achieve an energy density equals to some laser beam, a hot object would have to be at the temperature of 10 to raise power 30 K. So we can say that laser beam is highly intense light. As the laser mean light amplification by stimulated emission of radiation. So now we will discuss the key idea behind the laser applications, that how we can make the laser and what is the basic idea behind it. So what is the key ideas behind the laser application? Key idea behind laser. So the key idea behind the laser is the presence of more than one excited state. More than one excited state. So whose life is like 10 to raise power minus 3 seconds. So the second excited state have the lifetime of 10 to raise power minus 3 seconds, and usually the excited state has a lifetime of 10 to raise power minus 8 seconds. So the electron usually are can stay or lattice, or we can say the excited state can persist for a time of 10 to raise power minus 3 seconds. But this state, second is an extra excited state in the case of laser, has a long lifetime as compared to the normal excited state, that is 10 to raise power minus 3 seconds. So its lifetime is more than usual lifetime of excited state. So such a relatively long-lived excited state is known as metastable state. Metastable state. So here we can show it like this one. Here we have a ground state. This one is our ground state, and then above ground state we have metastable excited state, metastable excited state, and then above metastable excited state we have excited state. So let's suppose first we have electron here in the excited state, and then it will take a time of 10 to raise power minus 8 seconds from excited state to this metastable state, and from metastable state to ground state it will come in 10 to raise power minus 3 seconds. So metastable state is the state in which electron can stay for a long time as compared to the normal excited state. Okay, now we will discuss about the type of radiation, electromagnetic, involving the electromagnetic radiation as well, or possible between two energy levels. So usually three kinds of radiation are possible. Three kind of radiation, including electromagnetic waves, are involving the electromagnetic waves, are possible between the two energy levels E0 and E1. So let's suppose this one is our ground state energy level E0, and this one is the excited state E1. So there are the possibility of three kind of radiation. First possibility is that the electron is in the ground state, and which is the stable energy state, which is also called as stable energy. So when atom is in the stable energy state or in its lower energy state, it can raise to higher energy state. We can rise it to the higher energy state by absorbing a photon. So by absorbing photon whose energy is equals to h mu, which is equals to the energy difference between two energy level E0 and E1. So by absorbing this amount of energy, atom can be raised to higher energy state E1. So this process is called as induced absorption. It is called as induced absorption. So the second kind of radiation will be when the atom is already in the excited state, it will come down to its lower energy state by emitting a photon of energy h mu. So this process is also called as this process is called as spontaneous emission. Spontaneous emission. And thirdly, there is another process which uh, which is for example, when atom is in the excited state, then it comes down to its lower energy state by absorbing a photon absorbing the photon, and then as a result, so when atom absorb the photon of energy h mu in the excited state, and it comes down to its lower energy state, and so by emitting another photon. So emitted photon will be in phase with the incident photon, so it will produce highly coherent light. So that is, you can say that this light will be amplified as compared to the incident photon. So this process is called as induced emission. So this is called as induced emission. So this third possibility was first introduced by Einstein. Einstein was the first one who introduced this possibility in 1917. Actually, Einstein showed that the induced emission has the same probability as the induced absorption. The photon of energy h mu, which is incident on an atom in the upper state E1, and can cause the emission of photon to the lower state E0. So it has the same possibility so as that of the induced absorption. So induced emission is similar to the harmonic oscillator. So here now I will discuss that how it is similar to the harmonic oscillator. Let's suppose we have a pendulum, and pendulum is the harmonic motion about its mean position when we apply a sinusoidal force on it, and this force whose time period is the same as the natural time period of the vibration of the pendulum. So if this force is exactly in phase, then it will increase the amplitude of vibration of this pendulum. And this is similar to the induced absorption. Just like as in the induced absorption, when the energy is absorbed by the atom in its lower energy state, then it goes to the excited energy state. So when we apply the force, if the applied force is 180-degree out of phase with the pendulum wings, then with the pendulum swing, then the amplitude of the swing will decrease, and so this decrease in swing will correspond to the induced emission. Okay, how it corresponds to the induced emission? As in the case of induced emission, when atom is in its excited state, so in order to reduce, when it reduces its energy, it comes down to in its ground state. So the reduction in the amplitude of pendulum, which is in the simple harmonic oscillator, is correspond to induced emission, and increase in the amplitude increase in amplitude of pendulum swing correspond to the induced absorption. As because by absorbing the energy, absorbing the photon of energy mu naught, the atom goes to its excited state. So this is induced absorption. Now I will going to tell you that why three levels why three levels are necessary. Why we cannot choose the 2 level or 4 level, and why the 3 level lasers are necessary or compulsory. Okay, now 3 level laser. 3 level laser. So in 3 level laser we have the 3 states. First we have a ground state E naught, then we have a metastable state, and then after that we have excited state. So there are 3 energy levels, E naught, E1, and this level is can be named as like E2. So this is a 3 level laser. So in the 3 level laser, which is a simplest kind of the laser, here we can use an assembly of the atom in a metastable state. Assembly of atoms or molecules which are in metastable state. Metastable state. So when more atoms are in the metastable state, then when we after gaining this kind of the situation, when more atoms and molecules are in metastable state, and then we shine a light on the metastable state, then if we in this situation if we shine a light on metastable state of this assembly of atom, then as a result what will happen? As a result there will be the more induced emission more induced emission as compared to the induced absorption. So more electron will be emitted, more radiation will be emitted from metastable state, as will be there will be the more induced emission as compared to the induced absorption from E0 to E2. So as a result we get the amplified light. So there will be a light amplification. So here we can picture it like this one. Let's suppose we have a state E0 and this state is E2. So let's suppose here we have let's suppose we have electron in the ground state. When we induce when we fall a light, when there is a induced absorption, when the atom is in its lower energy state or ground state, then we fall a light on it, and then there will be the absorption of photon of energy h mu. As a result it will go to in its excited state. Then there is another state which is called as E1, which is metastable state. Metastable state. Now what will happen to these electrons which are in the excited state? These electrons after 10 to raise power minus 8 second, these electrons will jump from E2 to E1, which is metastable state. So here we have a spontaneous emission of photon of energy h mu. So these photons will be emitted from the metastable state. Now next what will happen? Now the electrons are in the metastable state. Here they can stay for a long time as compared to this excited state. So when the number of so in this way we can get a more number of atoms which are in the metastable state as compared to the atom which are in the ground state. So as a result, when there are the more number of atoms which are in the metastable state, as the we can say that atom can stay in the metastable state, can exist in the metastable state for a long time as compared to this excited state. So when we get an assembly of an atom and molecule, then we will shine a light on this metastable state by some mechanism. Then there will be the induced, as a result there will be the induced emission. So there will be the induced emission. So in this way the induced emission rate of this induced emission will be greater than the induced absorption. So this will result in the amplification of original light or incident light. So this will be the amplification of light. So this beam will be the amplified light beam. Here we use another important term in the case of laser, which is called as population inversion. Population inversion. This is another important term which is mostly used. So this term describes the assembly of atom in the metastable state. That is, it describes assembly of atom in metastable state. So this is called as population inversion when more atom or molecule are in the metastable state as compared to the ground state. So there are the number of ways to produce the population inversion, and so one of them is called as the optical pumping. So one of them is the optical pumping. So now I will tell you that how by optical pumping we can produce a population inversion. So how to produce population inversion by optical pumping. So in order to produce a population inversion in the metastable state with the optical pumping, here we use an external light source. External light source is used, and this light source has the photon have the right frequency which can rise the ground state electron to the excited state E2. So that can decay spontaneously to the metastable state E1. So let here we have an example of ruby laser, which is an example of in which we use the optical pumping method for the population inversion. So in the ruby laser, we have an ground state which has the energy of 1.79 electron volt and excited state energy is 2.25 electron volt. When we fall a light by optical pumping, that is by external light source optical pumping, then it will rise it to the excited state. In optical pumping we have a photon of 550 nanometer, and then in ruby laser we have an excited state, that is which is of chromium plus 3 ion, and then it will spontaneously decay to the metastable state. So in this way we can get the population inversion in the metastable state by an external light source. Now I will discuss why the three levels needed. Why three level needed? So let's suppose we have only a two level, that is a ground state and metastable state E1. So here are only two level, let's suppose. Although the two levels are not possible for the light amplification, so this is the ground state. So when a more photon of frequency mu we pump into the assembly of the atom, so there will be the more upward transition. So when we pump a photon of energy h mu, there will be the more upward transition. So after, however, at the same time, the pumping will also induce a downward transition as well from metastable state to the ground state. So after some time, when half of the atoms are in each state, so half atom are in the metastable state, half atom in metastable state, and half atom becomes half atom become in ground state. When we come in this situation, when there are the half atom in metastable and half atom in the ground state, then in such a situation the rate of induced emission becomes rate of induced emission, that is from metastable state to the ground state will be equals to the rate of induced absorption. Induced absorption from ground state to the metastable state. So in this case, this assembly cannot ever have the more than half of its atom in the metastable state. So in this situation, the laser amplification cannot occur. So we cannot achieve the population inversion in the case of two levels. So there must be a three level. So when we have a three energy level, so first atom will de-excite to the excited state, and then it comes down to the metastable state. So for induced emission, we have enough atom in the metastable state. We can achieve the population inversion only when we have a 3 energy level. So 3 energy levels are necessary, and so these prevent the pumping from depopulating the metastable state. So in 3 level laser, more than half atom must be in the metastable state for the induced emission to predominate the induced absorption. So now I will discuss the 4 level laser. So 4 level laser. In the 4 level laser, we have a 4 state instead of 3 states. So E0, which is ground state, and then above ground state we have another state which is called as intermediate state. E1, and then we have another state E2, which is called as metastable state. And above metastable state we have E3, which is excited state, which is called as excited state. So when by the pumping or by the any type of the like optical pumping, there is the transition from ground state to the excited state. So this from this pump state, the atoms comes to the metastable state. So this will be the initial transition from excited state to the metastable state. So this is the first transition, and then from metastable state, which is the laser transition, that is the amplified light transition, as the metastable state is the most populated state. And so these are the laser transition, and then from metastable state the laser transitions are in the intermediate state. So intermediate state, here we have only a few atoms. In the intermediate state, because this is a highly unstable state. This is highly unstable state and it rapidly decay into the ground state. So there are only very few atoms are in the intermediate state. So with even with the moderate type amount of the pumping, we can populate the metastable state, and so to a greater extent than the intermediate state, which is required for the light amplification. So intermediate state is the very unstable state. It will get rapidly decay into the ground state. So this was all about the laser, and in our coming videos we will discuss about some practical kind of laser. Thanks for watching. For more videos, please subscribe our channel.